Time is an illusion. We know that. But how do we know that? How do we prove that? Well, science can prove it in at least 3 ways. Number 1, time is relative. Albert Einstein turned 140 this year, or maybe it was last year. Depending on where you are in the universe, Albert Einstein's birthday could be next Tuesday, or it could have been last Tuesday. Einstein showed us that time isn't absolute, doesn't pass the same for everyone. It depends on your frame of reference. If you're sitting still, time passes more slowly than if you're moving in a rocket ship traveling near the speed of light. This has been proven by experiments like the Haffel-Keating experiment, where they took atomic clocks on planes and flew them around the world eastward and westward, and compared them to clocks that stayed on the ground. The clocks that flew around the world slower, depending on whether they went east or west, confirmed Einstein's theories. So there are times when it makes sense to say that time stopped or time slowed down. That's because it did from our perspective. But really, time is always passing. You could say it's passing faster on some clocks than others, but that's only because we're not taking all the clocks with us. We'll leave some of them behind. So when we come back, we see that those clocks have passed less time than ours have. But really, they were both passing at the same rate. No. 2. Time is not the 4th dimension. Our 3D space plus time is really just 4D space-time. You can travel in space, and you can travel in time, but you can never travel in time alone. You must always travel in space too. So if you think about it, time isn't even a dimension. That's why it's called the 4th dimension. Because really, we're always in the 3rd dimension. We're always in space. Space is where we are. That's where we're located. Time is what's happening to us. So from that point of view, time isn't a dimension at all. When people talk about higher dimensions, they're talking about other spatial directions. Like if you lived in just 2 dimensions, then you couldn't move left or right, only forwards and backwards. If you lived in 3 dimensions, you could move left and right and forwards and backwards and up and down. If you lived in 4 dimensions, you could do all that plus another direction, a 4th direction. But being in 4 dimensions would unfeel any different than being in 3 dimensions, except you could go in this 4th direction. Being in 4D space-time wouldn't feel any different than being in 3D space, except you could travel in time by going faster or slower, going near the speed of light, or going in a gravitational field. So the idea that you can travel in time alone, the idea that time is a dimension, is really just a misunderstanding of what dimensions are. And finally, number 3, time may not exist at all. This is kind of a weird one. Let me explain. What we call time is really just change. We say time is passing, but really things are changing. The reason we think that there's something called time passing is because we see things change, cause and effect, action and reaction. One thing follows another. We call that time passing, but it could just be change. In fact, in physics, we don't have a fundamental law that says time passes. There's no such law. What we have is a set of laws that describe change, how one thing follows another. Newton's laws and Einstein's theories describe how things change. They describe how clocks change, how calendars change, how seasons change. But they don't say anything about time. So some physicists will say, time doesn't exist, there's only change. Now, of course, we all know that if you stop time, if you stop change, if nothing changes, then people stop breathing and plants stop growing and planets stop orbiting. So the universe would stop working. So we need change. We need cause and effect, action and reaction, whatever you want to call it. But calling it time may not be accurate. Calling it a dimension may not be accurate either. So next time someone asks you what time it is, you can say, well, that's a complicated question. You want to know what time it is? Well, it depends on how fast you're moving. Are you moving near the speed of light? Are you in a gravitational field? And then you can tell them how many minutes or hours or days have passed on your clock. But that doesn't mean that time passed. It means your clock changed. It means some things changed. You changed. I love questions like this. If you have a question about something that's confusing, or maybe you'd like me to clear up a misconception, send it to me at the email below. I might use your question in a future episode.